broken it by changing these. Yeah, now I hear myself. Okay. Let's back where we at. Okay. Okay. So I messed up my OBS settings by trying to record something else earlier this week. Now I must pause myself. Let's see here. Okay. Now we're not feeding back into my ear. 1 minute. I'm gonna take my hoodie off and then we will get started for real this time. Okay. So, as I was saying, but you could not hear, on this stream we'll be working with CircuitPython. We'll be writing a library that is going to run on this Raspberry Pi Pico. If you're brand new to the stream, if you've never seen anything like this before, these are little microcontrollers. They're basically just a tiny computer with a bunch of available I/O pins, input-output pins. You can connect up other hardware devices like sensors and displays and LEDs. You can write Python code that goes on this device and it will control all the things that are connected to it. If you are interested in the CircuitPython project and you want to get involved, you go to circuitpython.org. This is the website for it right here. There's a contributing link up at the top. This is going to take you to a page that shows all of the open pull requests and issues. And on this page, you can find ways to help contribute to the development of the CircuitPython libraries. You can look through the pull requests, you can find one that interests you, you can go and review it, you can test out the code for it. On the issues side of things, you can find issues that have been logged, but there is not a pull request for it yet. So you would look into the issue, decide if it's something that you're interested in that you think you could do, and then you could go and make a pull request to resolve that issue. And a lot of the issues that we have right now are these missing type annotations. And these are also counting towards Hacktoberfest. So if you are taking part in DigitalOcean's, I think they're the primary sponsors of Hacktoberfest, you can complete these type annotation PRs and get credit towards the Hacktoberfest thing. I think they give out a certain number of t-shirts or something like that. So if folks are interested in doing that, of course, if you watch this during the month of October, if you're watching this after the fact, then it may be over if it's not October anymore, but you're definitely still free to contribute anyway. We definitely love to have you. If you don't want to contribute on the development side of things, but you still like the CircuitPython project and want to find a way to help it, another thing you can do is purchase hardware from this company right here, Adafruit. This is their website, adafruit.com. They sell hardware devices, microcontrollers, all sorts of sensors and things that you can hook up and do with the microcontrollers. So they are the primary financial backers of the CircuitPython project. They pay the core development team to work on CircuitPython full-time and to foster the community around it and do all sorts of neat things with the project and the community. So if you purchase hardware from them, you are indirectly supporting the CircuitPython project. This stream is not like a paid stream. They're not paying me to promote their website here. This is just a thing I like to mention up at the top of all the streams because, of course, I'm involved in the CircuitPython project. I want to see it spread wide and far and succeed as much as it can. They do pay me to work on guides and to work on other software from time to time. But this particular stream and my mentioning of their stuff for sale today, this is not a paid endorsement or anything like that. So, like I mentioned, today we're working on a library for a little device that I picked up that goes on the Pico. I should have kept some of these tabs open. Let me see here. Let me get this one. And let me also do this over here. Okay, so I picked up this device. It's a Waveshare brand Pico LCD 1.14 inches. So this is a, honestly, it reminds me of a, like a feather wing, basically. It's a form factor that plugs straight onto the Pico. It's got female headers right there. The Pico's male pins plug into those female headers. And then this is basically the underside of this device, and then this would be the top side. So it has a little 1 1/4 or so, 1.14 inch LCD right there. It has a D-pad type device. It can has all 4 directions: up, right, left, and down. And you can also push straight in to get like an enter action. So there's 5 total buttons on that device. And then you have an A button and a B button over here as well. The display is connected via SPI, and then all of the buttons are just connected directly to a single I/O pin. So what we're going to do today is write a helper library that will initialize the display, set up all the pins that the buttons are connected to, and just make it super easy to use this piece of hardware in some other programs. So, we could write all of that stuff directly into our program, initialize everything, and then use it. But it'd be nice if we had like a high-level library. We just import it, we initialize it, and then it takes care of everything for all the different pieces of hardware, the buttons and the display, wrap it all up into a nice, easy-to-use object. I got this from Amazon. I'm sure they're probably available elsewhere. But I'll pull up the listing that I happened to get it from. It was, I think, $13 or $15, something like that, right in that range. It's going to be tough to find in this Amazon that doesn't have all of my history. Waveshare. Yeah. We'll give it one more try here. Amazon's tough sometimes for searching things, honestly. Waveshare Pico. Let's see if that gets us there. Okay, hey, these ones are similar. Yeah, here it is. This top one right here. So it looks like they actually have one that's a different size as well. For the same price, you could get a 1.3 inch display. It's a little more square than rectangular, and it looks like it also has 4 buttons on the side there instead of 2. And then they also had one that was 2 buttons on one side, 2 buttons on the other side. So there's a couple of different variations of this hardware. This is the one that I got. So this is the one that we'll be writing the helper for. And so this has got all the same stuff, a couple pictures of it there. So if folks are interested in picking up this device, this is where I got it from Amazon. But if you search Waveshare Pico LCD, you could possibly find it elsewhere. I'm not super sure where Waveshare, where all the places that it's distributed are. So I have the screen already set up and initialized, which is probably the hardest part of this particular library, is getting the screen set up, but it's really not that hard either. Lots of the work that has gone into display I/O has made it very easy to initialize displays, honestly. So I'll give you a look at what I have so far, and then we'll start building the library. So basically right now I'm just running a simple test example script from the ST7789 library. This is the control chip for the LCD that happens to be on this device, and CircuitPython already has a driver that can interact with this control chip. So really all I had to do to get this hooked up was find the right pins, which are all mapped out in this page right here on this nice pretty diagram, which we could get by itself. So DC is on GP, well, it would be, I think, GP8. Yeah, over here they say better. DC is on GP8, chip select is on GP9, clock is on GP10, data is on GP11. We're only sending data one way. It's only going from the microcontroller to the display, so we don't care about data coming back the other way, so we just have the one pin there. Reset is on GP12. Backlight is on GP13. And then the rest of the buttons are listed around here as well. A, B, and then the joystick directions and center press. So using these pins right here for the SPI bus to connect up the display, we were able to make a SPI instance, SPI bus, basically, using bus.io. The Pico device is sort of unique in that it does not have, let's see here, dev, let's pull this up, and let's go REPL board. So lots of devices on the board module, they'll have a SPI, like board.SPI or board.I2C or board.UART. They have some buses that are ready made. They're built into the firmware. Oh, nice. Yeah, so that's the Pimoroni one is actually how I started looking for this. I saw a couple PRs go by where folks were adding examples for the Pimoroni displays, and I started searching around for those displays on Amazon because Pimoroni, I think they're based in the UK, not 100% sure, somewhere in Europe, but their shipping tends to be fairly expensive over to me. So I was looking for Pimoroni hardware on Amazon, and that's when I came across this one. It would be nice to pick up some of the Pimoroni ones too, though. I think they always have lots of neat hardware, especially around the Pico. I've noticed they have lots of cool little add-ons that go to the Pico. But yeah, it's very, very similar to that Pimoroni device right there. And also, welcome, Dexter. Hope you're having a nice day playing with some ESP32 and Whippersnapper. Nice. Need a Whippersnapper emoji? Yeah, that'd be cool. I wonder what would it be? Maybe a whip. Blink of snapping a whip or something. Anyway, this device, it doesn't have the buses made up. Whoa. It doesn't have the buses ready-made on this device. I think it's probably because, my guess is that it's because they're not labeled. On the Pico Silk screen, if we pull up a... ooh, that looks neat. Pico, let's just go Pico. Yeah, we could do this. Maybe this one. I wish I could just open the pictures. I guess I'm on the wrong row for that. I see one picture with the top and the bottom, so it looks like too much. Okay. Oh, there's one. Okay. Let's get this one. Let's just open the image. So on the Pico, of course, all the pins are labeled on the bottom on this device instead of the top, but there's none of the pins are labeled as SPI buses or I2C buses or anything like that, right? There's no, MOSI or MISO or clock, CLK, SDA, SCL for I2C. None of those exist on the Silk screen for this device. There are pins that are built in that are meant to serve those functions, which we could find on the card. Can we find a nice big picture of the pinout card? Pi Pico pinout. Yeah. Let's look at this one. So some of the pins, like, you see a lot of them are labeled like I2C1, I2C1, I2C0, and then in the red column here, there's some SPIs like SPI0, 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 SPI1. So it has pins that are, built in that are meant to serve these functions. They're just not labeled on the Silk screen. And the board module in CircuitPython tends to follow the Silk screen, so they're not listed there. Therefore, we need to use bus.io in order to initialize the SPI bus. GPIO 10 is our clock pin. GPIO 11 is our data pin. And again, we don't care about the second data pin since we're only sending data one way. Then we just set up chip select and data command DC pins. Those are on 9 and 8. I had these backwards originally, and I got some nice static on the display. So if you're ever setting up a display and if the display is turning on, but you're just getting a bunch of garbled, colorful static, one thing to check is make sure you have your pins in the right order. That was my mistake. We set up a 4-wire bus with SPI, with our CS and our DC, and then we also tell it the reset pin, which is on GP12. From there, we can initialize the display. We give that display the display bus that we set up. And then these are kind of the magic numbers that work for this display. It turns out it's mounted such that we want a 270-degree rotation. Width and height are there in pixels. It's 240 pixels by 135, which is kind of interesting, 135, that it's a an odd number of pixels. It's not a power of 2 or anything, or even divisible by 2. And then these, I'm not 100% sure what these are. These just came from the example, and they turned out to work. So I assume that's some kind of standard. Possibly the driver chip can drive a display that's bigger, but this particular display is actually smaller. And then these are like the coordinates where the sort of virtual, real display is located inside the driver chip. I'm not 100% sure on all of that, though. From there, it's just a basic display I/O script. So all the rest of the stuff that we have here is just create a group, create a bitmap for the background, tile grids to hold it, another bitmap for the foreground, the smaller rectangle with the other color, and then create a label with display text, put some text in there, and put all of that stuff into our group, and then we're able to show it on the display. Back here we told it to display the group. So that's what we have so far. Let me catch up on the chat here. Looks like a bunch of neat things have been shared. I have an expander. Okay, yeah, that is interesting. I wonder if Pico will become kind of like I wonder if that format will become a standard like Feather has. I mean, obviously it is, right? Because I have this device. It looks like the expander there exists. So I wonder how many of those little add-on widgets will come around. It seems like a nice form factor to be able to just plug something in on top of. And of course, the Pico price point is tough to beat. Well, the info says UK. Guess they're imported for sale. Yeah, I should print out the pinout. I pull it up in Google Images every time. Wonder if we could redefine the display while the code is running to switch between static and functioning. You probably could. I mean, you could initialize it once and draw something on it, and then uninitialize it with release displays, and then initialize it again with the pins backwards. And then that would show you static, and then I assume you could just keep releasing it and reinitializing it, alternating with correct pins and incorrect pins. I would guess something like that's possible. I've not tried it specifically. So we want to basically factor out all of this setup stuff that's above here. We want to take all of this and drop it into a library. So I think what I'm going to do is, how do we want to start? Do we want to start just coding directly on the device, or do we want to go and cookie cutter up a library? Because I think what I'll do is eventually add this to the community bundle for other folks that might have this hardware. I think I'll start by cookie cuttering of course we got to do that from the terminal. So we have a cookie cutter somewhere. Let's see. Let me open cookie cutter. Let's make sure we're on the main branch and everything. This is going to be repos. No, this is going to be home. Then repos. CircuitPython. can never remember, is it CircuitPython cookie cutter? Is it cookie cutter Adafruit? Yeah, there we go, cookie cutter Adafruit. Let's go new window. And it looks like I am on main right now, which is tracking Adafruit main, so that's good. Let's pull. All files up to date, that's good as well. So there should be inside one of these the command we need. So this is inside of cookie tests. That's not really where I want this. So I'm gonna go, I guess I'll just use the other terminal maybe. Keep this one here because I like having it for when I do tests on the cookie cutter repo. I could always take it back, but this one's already in closer to the right spot. We'll go CircuitPython, cookie cutter, cookie cutter. Does it need a slash? Yeah. And this. So this is going to be a community library. GitHub user is foamyguy. Author name is me. Company, I think I usually end up just putting foamyguy for that as well. I don't actually have a company, but that's all right. Library name, we'll name this based on the device, which was not that browser. Yeah, hide that back. The other thing you could do to achieve a glitch effect, instead of actually initializing the display wrong with the wrong pins, you could draw a bitmap and then put a lot of different colors in the palette, and then just randomly set the pixels to random colors. I assume that would make it look pretty similar as well. I guess what it's doing when it draws that static, it must be dumping memory onto the display just in the wrong way. Ends up being just random colored pixels. So yeah, using a bitmap might be a way to do that as well without having to like deinitialize and reinitialize the display. In that case, you could actually get like stripes of it as well. If you wanted to make a little bit of a vertical stripe or a horizontal stripe, or the bottom half of the screen or something, like half the screen could be showing something real that looks correct, and then the other part could be showing the static there. So I'm going to call this, I think we want to include wave share. I think we'll call it wave share Pico LCD 114. So let's go wave share Pico LCD 1. I just want to do 114 or 114 like this with an underscore instead of a dot. I think I'll do it like this. 114. Okay. That's the library name. Library description is a helper library for wave share Pico LCD plus joystick plus buttons. I'll just call it an add-on. I'm tempted to use the term wing because it's so similar in nature to a feather wing, but of course it's not the feather pinout, and I don't know if I don't know if wing has like a specific meaning necessarily. Add-on device. If I have like a part number, I'll include that as well. I don't know. Maybe we'll put the model of the control chip. Maybe we'll put the size of the display as well. Display 240 pixels by 135 pixels. That's probably good. Keywords, display IO, display, Pico, LCD. We'll even throw stuff like joystick because it has a joystick on it. I'll put, do I want to put Raspberry Pi? Probably folks would be expecting the big Pi, not the Pico. Maybe Raspberry Pi Pico like that. That's probably good. Prefix, we'll go with foamyguy. Product ID doesn't have one. It's not a not native fruit product. I don't think. Do they sell any WaveShare stuff? I'm not sure. So I kind of doubt it, right? WaveShare? Oh, maybe. Is this? No. I can't actually find anything. Okay. Yeah, I'm not sure why it ended up returning this stuff. Maybe they have displays or something that happen to be WaveShare brand, but not this full like breakout. Does it require bus device? Yeah, it does. I mean, it's built into the core at this point, but it does require it. Register, yep, it's gonna need that. Other requirements, no, not really, right? It's gonna be, so, you know, display IO is built into the core. The buttons, I think we're gonna handle them with, I think I'm gonna use keypad to handle the buttons, which is also built into the core. So yeah, I don't think we have any other requirements. PyPy, yeah, we'll release it. Will we release it on PyPy? I guess it's meant for microcontrollers only. Oh, nice. Change the PID. Yeah, I think I saw that. I saw that PR go by. Did that get merged yet? I guess I can check on that in the terminal here in just a minute, or I can maybe start a new one. I figured out recently this GHPR list. This is a really cool command. We'll list all the open PRs. So it looks like, yeah, it must have got merged. Awesome. Yeah, and well, yeah, of course it got merged, right? Because I have the up-to-date version and it says product ID. Yep. Okay. Do we want to release on PyPy? I mean, I guess not. It's not really intended to work on Blinka in the Linux environment, so there's not too much of a reason to install it with PyPy. I suppose there's no harm in releasing it that way either, but it's not really going to help that much. I guess, if anything, the benefit would be installing it on the PC in order to get the typing information into PyCharm and stuff like that. Yeah, I guess I'll do it. Let's do yes. That way people can install it and see it in PyCharm. Sphinx, yeah, we'll do Sphinx stocks as well. Okay. So now we should be able to open that new directory, which should start with foamyguy. Guess I could have put display IO in it as well. We do that sometimes. That's all right though. Let's open this new window. Okay. Tempted to drop foamyguy from the name of the module. Seems excessive there, I think. It's in the name of the repo, which I think makes a little more sense, even though it actually has the username there as well. Not sure what all will break if we change the name of the module. I guess I'll just leave it for now. Okay, let's work on a couple to-dos and then we'll start putting actual code in this. Links to hardware. I guess we could link to a couple of these pages, right? We could link to the docs page, which is here. Okay, so what's the format here? Interesting. Okay, do we need the quotes? No, I don't think so. So star, I don't usually do these by hand. I usually end up going to find a thing to copy paste. Link text, so wave share, documentation, space, these things, URL, tick mark, underscore. Yeah, okay. I'll add one as well for, I guess, the, can put the Amazon link. I guess that one's more likely to rot, quote unquote, link rot. So like, I assume this will run out of stock and then you won't be able to find it at that link anymore, even if they still have some in a different listing, but all right for now. Is this what we ended up with? Yeah. And we don't actually really need all of this stuff, right? I think I can take just this part. Yeah. And Amazon purchase. Yeah, PID was not, I mean, basically just not as specific as it could have been, and other folks use that acronym for different things. Okay, so we don't need this part anymore. Software dependencies, we don't really have any besides CircuitPython. I mean, I guess bus device and register, yes, but bus device is technically part of the core now. Register, I suppose it still needs. I guess we'll put it like that anyway. Okay, so there's our to-dos in this file. I think there's going to be a few more maybe over here. To-do. Remove the note above if PyPy will be available. So yeah, we clicked yes on PyPy. We'll take that out. Eventually, maybe I'll change up this text to indicate that you can install it from PyPy, but not, you know, you obviously can't install it onto a microcontroller from PyPy, so it's only for IDE help, basically. We'll leave it alone for now. The actual install steps would be the same. Let's see if there's any other to-dos. Yeah, example. We're going to make example code for it. I guess I'll leave that one until we actually have it, though. Let's see. I think there's a couple more to-dos. Yeah, auto doc mocks. We need a couple of these. We need display IO for sure. Bus IO. Yeah, I guess we will need bus IO, right, to create the spy bus. Keypad? Keypad we're gonna need eventually. I'll leave it there for now, and then we can add any others that we come across. Any other to-dos here? No, so these ones always flag my thing, but they're not actual to-dos. These are talking about what to do if to-dos are found. there any other? Yeah. Learn guide links. There won't be any learn guide links. Maybe I'll make a README page that's like talks about wiring and points to the diagram and stuff, but related products. No, there's not going to be any related products. All those look good. Okay. Email. Whoops. I guess we could put link a display IO. Put blink a display IO in the requires, and then we would not actually need the mock docs, I think, right? Let's try it that way. It's always better to use a real module instead of the mocks, I've come to find out. I think this is probably the right name for blink a display IO. Let's look it up though. Yeah. Although it's not capitalized. I don't know if it matters. I'll put it in requirements also. Okay. We don't really need the to-do. Okay. So I'm going to model this after the Featherwing library. There's a Featherwing library that has a bunch of these helper devices in it. Some of them are for displays, which is pretty much what we're making here, so I'm going to model it after that. Say something like TFT Featherwing. Or isn't there one with a joystick and a display? Or like this one? I2C. Tutorial. Let's have a helper library. Does it just point you to the display? Yeah, it points you to the display. Okay. We'll head back to here. What's Joy Featherwing? Does that one have a joystick and a screen? No. Joystick and buttons. Okay. So we'll just look at TFT Featherwing, I think. A couple of different sizes. Doesn't really matter which one, although it would be nice to have one that's not. Let's have a display. It'd be nice to have one that's not subclass and superclass, because we're only going to have one. Power monitoring, that's not what we need. Keyboard Featherwing, I guess, as a display. Oh, but this is also extending TFT Featherwing. Okay, well, we'll start here. We'll just deal with the superclass, subclass thing when we get to it. So we'll have a class, we'll have initialize class, we're going to call it something different. Wave share Pico LCD 114. We're not extending anything. We could put the comment. We could add parameter doc strings as well if we wanted. Okay. Init function. Oh, I hid the chat. Let me pull that back. There we go. So this is going to need to accept some parameters. Honestly, probably the same ones as this. Maybe also a reset. And we will make defaults. These are all defaulted to none. We'll make defaults that point to the pins it's hardwired to. So if someone just plugs it in, then it'll work. They won't have to actually fill these in. But if they, for whatever reason, wanted to wire it differently, they could, and they could change these parameters. So we don't actually need, we don't have an SD card. Yeah, do this. So SPI bus, a chip select, a DC, and we only have one chip select DC. I will put a reset. But none. We're not actually going to use none though. We're going to use pins that they actually are. B12 on the reset. CS is 9. DC is 8. We will need to import board, Product requirements. I mean, Blinka is listed, which has board. I don't know why it says that. Pass. Let's just fill that in for now. SPI is going to be none, and what we'll do is if not SPI, then we do this one. I guess we could have all of this line. I have a key that does lines, actually. SPI. So we'll say self dot SPI. Do we want underscore SPI? Does it matter? Yeah, let's do an underscore, I think. Import bus IO. Ooh, the imports went down here. Interesting. How are these in a real one? These actually like that? It's under the... Okay, we don't have a top level comment yet. Where are those version things, though? Interesting. We don't have those version things in this file. I wonder why that is. Those are for PyPy only, maybe? I don't know. Okay, this needs to be the name of the file. We're not going to be in a module, we're just going to be a single file. I guess we do have this up here actually, right? Yeah, we already have this up here. I guess we could include this one. Oh, we already, and in fact, actually that is already there. Okay, yeah, we don't need this. Okay, if they don't get past the spy bus, create the spy bus with bus.io. We don't need pass anymore. We can initialize the display. Where did my... There we go. Okay. Go back to workspace. Okay, so we create the bus, we create the display. We should call release displays. Maybe first thing. Oh, that's what we should have put as another requirement is driver, display driver. Yeah. Let's see here. We should put this in here. We should put it in here. Unresolved. Guess we could install it. Okay. This is going to be self.display. These are... I think it's really a TFT screen, so I'm going to leave that part off. Okay. This should be reset. The parameter. I want to try to make the stubs board contain a property for every possible pin from every possible board. That way these would not be yellow. I don't know if that's feasible though in the stubs like creation process to parse all the pins on all the boards and then fill them in the stubbed PYI board file. I think that would be kind of nice. I guess we'll keep the bus as well. I don't know that we would need it for anything else, but better to have it and not need it than not have it and find a reason to need it. Okay. So that might be all we need for the LCD, I think. Yeah, we would create a group. We would then show the group on the display. Okay. So, at this point, we could make a simple test, which would be actually going to be MIT. I think we started getting rid of the duplicate lines there. Maybe we should fix that in Cookie Cutter. I don't really need this part, it's because I filled in a company. Okay, so we will, from this import class, waveshare Pico. while true. Pass. We want to make a group. Main group. Group. Whoops. From display.io import group. Group. So we initialize the display. I think we can just use all defaults, and then now we could say lcd.display.show main group, and we'll just do the same sort of green purple hello world. That's kind of like the it's kind of like the stock simple test for lots of display-based things. Next group. Okay. So I guess we need more display.io things. Why don't we just do that? Actually, I kind of like not having to list them here from import. We'll just get all of them. Group, tile grid, bitmap. Okay, so we don't need these. Oh, we need palette. Palette. Whoa, too much. Okay, my splash is not called splash, it's called main group. I'll fill in display in a minute. Okay. In fact, what we'll do is we'll just say display equals LCD display. And we don't need that. Come on. Oh, we'll get an extra line. I'm gonna close this. Okay. Okay, how big is the border? What scale is the font? Color is the background? What color is the foreground? What color is the text? An extra one of these. Label we need to import. And I actually want to use bitmap label as label. Terminal IO. Getting pretty close now, yeah. Okay. That's looking good. So basically we took all of our initialization and crunched it down to one line, which is nice. It's not a super huge deal at this point. There's only, 10 or so, maybe a dozen lines or something at this point. But the a big benefit that we'll get is when we also implement all the keys, all the buttons will be inside of this one line as well. And those will definitely add more size that we are refactoring into this helper library. So let's run this. We'll put this in CodePy. It's going to fail because we don't have the library on the device. I'm going to keep the old CodePy. It's like something like this, I think. Python file, code, paste. So I'll save this, but it should fail. Yeah. So we want to take our library we have just created, put it into lib. Now it may succeed. Although we don't get anything on the screen. Let's see. Yeah. I tend to keep pretty much anything that's not a simple test, and even sometimes I keep the simple test like this time I did. Let's see here. Did I... what just happened? My stuff is gone. That stuff didn't save. Huh. Now lib is gone. Uh-oh. Ah, the whole device is gone. Okay, well that's not good. Let's give it the old Pico reset here. Disconnected. Stream died for a second. That's good to know that it's not just the Pico messed up. So we no longer have a device. I don't have an AMC, anything. ACM. Well, what did we do? We must have corrupted something, I guess. So let's grab this. I don't know what version I was on before. Okay. So this device doesn't have reset button, so what you do is hold boot select while you plug it in. And I actually have buttons on my hub. So I'm gonna hold boot select and push the buttons on the hub. And there we get our bootloader drive. We'll paste this. Well, we seem to have wrecked something. So how do we get it back? It's not connecting to... It's not connecting to the REPL. How do you get to safe mode? Can you get to safe mode on a Pico? Well, this is a bummer. No, that's alright. I'm gonna break another one. This page doesn't say anything about safe mode. Let's see if anyone in the chat has any ideas. Boy, this is kind of a bummer. I guess... I mean, there's only one button. Reset button. Or not, well, not a reset button, it's a boot button. So maybe something like press it when... Not hold it while you plug it in, but press it right after you plug it in? There's so many. Power off. Power on, press it. Didn't get anything. Nothing here either. Off. Power on, press it longer. No, the boot drive shows up. If I hold boot and I reboot it, the boot drive comes back. So I'll do, that's what I'm doing right now. Can't see the camera right now, but I held boot select and I essentially plugged it out and back in. I just used the button on the hub though. So this shows up, but as soon as I write CircuitPython, it just goes back to the same state. So we go CircuitPython. I don't really have a super easy way to not plug it to the hub. And I guess maybe I can try it real quick, but I can't do the whole rest of the stream with it. I don't have wires and everything hooked up for that. I don't know. I've never had any issues specifically with the hub either, I don't think. Yeah, I don't know how to nuke it though, right? Like reinstalling CircuitPython So the storage, like if I could get to the REPL, I could format the storage, which is also a way of nuking it, I guess, right? But I can't get to the REPL, so. I agree I need to nuke it, but I don't know how. I agree I need to reset it in a more strongly type of way than what I am currently doing. Stay away from nukes because they're bad. Nuke UF2. Where is this? Why is this not on the troubleshooting page? Press reset. There is no reset. Press reset during the 1 second wait. Okay, what do I want to do? I kind of want the files that were on it, truthfully. So I guess we're going to try to wire this to a reset button. Captain Resetti. Yeah, that would be nice. I should get some of those. Yeah. I'll be right back. I'm going to get some stuff to wire up a reset button. Okay. Breadboard, wires, button. Oh yeah, that's a good idea. Solder the button straight on. Alright. Let's put this back. Yeah, I need to get some of those Captain Resetties. That'd be really nice. Maybe I'll make a big order from Piemaroni. Do they have, maybe I can combine shipping. Okay, let's go to the camera, I guess, right? Let's try to see if we can at least show what we're doing. So I'm gonna put the button in. Actually, I'm gonna do it this way. Legs are a little bit too wide. I don't even know if this is gonna work. Okay, I can't use this button. I'll be back again. No, my editor does not keep the files open when the device disconnects. I don't think. I don't know, maybe it does. I don't think so. It probably could. I don't really want it to, truthfully, though. Because if I see the files there, then I want to be able to save them. And if save isn't going to work, then, like, I don't really need to see the files. I guess in this case, it'd be nice I could copy it out of there. There's probably a cached copy of those files somewhere inside of the idea folder, too. I don't know for sure, and I don't want to necessarily go digging for that. Okay, button, wires. Let's make sure this is wired the right way. Continuity. Okay. Yeah. That's a nice one too. Is that a side button? That looks like it. go. Okay, and of course, now it's around the back. We are this way. A different pinout. What is reset? Is reset run? Yeah, okay. Ooh. Is there a main guide for Pico? No, diagram. It's the same thing though. Okay. So that is 30. Boy, that's right in the middle there, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11th pin down from the... and of course I left no room. Alright, I'll be back again. Okay. Goes back out. It goes back in with pins on both sides this time. Eleventh pin down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ground is 2 past that. Yeah. So 11, 12, 13. Okay. So I'm gonna hold boot select and boot it into the bootloader. We're gonna get RP2 drive, then I'm gonna press reset and make sure that it resets. Reset. So just reset, and it does. Okay, we have a reset button wired up. Hey Johnny, we are, well, right now we're a couple of meters down the rabbit hole, if you will. But I was trying to write a library for this Pico add-on LCD device right here. This device plugs into the Pico, or vice versa, the Pico plugs into it. And I was working on writing a driver for this, and then my Pico went sideways on me. So now we are trying to get it back by going to safe mode. So we are gonna unplug it and then plug it back in and then press reset right after we plug it in. See if we can get to safe mode. Aha. So not CodePy. So one thing I can do is so we're in device workspace, Pico. So there's a sync command on this CLI. Sync. Root local dot. Yeah, that's what we want. Link sync defaults. Okay. Now we have a copy of everything that is on the Pico on the local computer. So let me catch up here. Latte sounds good. Had some coffee this morning, but some more does sound pretty good. Nice iPad stand. Yeah, that's my guess as well, is the reset button saved cost, either the actual part itself, but also maybe engineering cost, like might have had to spend more time and engineer effort on rerouting the PCB. Okay, let me get back to here. Oh, that's interesting. Didn't solder it. Interesting. Okay, let's close that. Let's see. So we have now not code. So does it reboot normally now? This will tell us if CodePy was breaking it. Does. So let's think about for a minute why CodePy could break it. Let's take some stuff out. We just initialize the display. Dang, 15 hours of sleep. Yeah. What if we also go to REPL? But put this. Okay, so the initialization doesn't complete. And is this gone now? Let's seem gone. Yeah, it totally is gone though. I can't save. Yeah. So, reset button? Comes back because it was not code. Maybe we will not be making a library for this. What? Why would... Why would initializing the library brick the device temporarily? Of course, I don't have the display plugged in anymore. But this does run and doesn't brick the device. So why would the same code inside of a module cause the device to get broken? Okay, we're gonna put print statements after each step. Missing anything? Yeah, this is bizarre because this is the same code. Release the displays, set up the SPI bus. Uh-huh. Yeah. That's needs to be this. So if you pass none to 4-wire, does it break your device? We'll test that in a minute. Does this work now? So if I save this, can I import not code? Reset. Import not code. Yeah. Yeah. Yep. Okay, so I mean that's a bug in CircuitPython, right? It should raise an exception, shouldn't it? Let's see if we can distill this a little bit further. 4-wire crash. So you probably don't need anything except display IO. So if we put none, none, and then we fill these in, I don't know, DC was GP8, CS was GP9, reset is 12, reset 12. Yeah. Print after initialize display bus. Let's call it 4-wire bus. Okay, reset. Import 4-wire crash. V8's in use. Why? Oh, we do need release displays. We do need release displays. Because we have the previous instance. Reset. Import 4-wire crash. Yeah, there we go. Okay, let's make an issue. This is not the right spot. I guess let's search the issues. 4-wire. Is it capitalized like that? Ah, device is gone. 4-wire. None. Spy. Look like it. Okay. Welcome back, Doctor. We've narrowed it down. The problem was passing none as the spy bus. Does not like that. This is a bug report. Passing none for spy to 4-wire puts device, puts Pico in broken state. Okay. Python version, code REPL. I'm gonna reset it. Reset button. Gonna rerun sync, which will, I think, update the files. What happens when you run the code above? Goes into a broken state. No CircuitPy drive, no serial connection. If the above code is in code.py, the device will never successfully boot. You must go to safe mode in order to regain access to it. No error messages printed to serial. I mean, I guess maybe it does, but we can't see it because it crashes so hard. No error messages are visible in the serial console if it's open at the time the code runs. It does disconnect within a few seconds of this code running. Ideally, I think 4-wire should check for none and raise an exception. Instead of soft brick device. If possible. Okay. We're gonna continue a little further down the rabbit hole here. I do want to get back to writing the library, and I think that I know what the issue is, and therefore I think I know how to fix it, and therefore I think we could move on, but I'm kind of interested to peel back the curtain a little bit more and look inside of this initializer function and see if we can't fix this. Again, it's not what I had intended on working on, but I'm kind of, I got the bug at this point. I'm kind of curious to give it a try. So I think this is looking good for an issue. We got the version, we got the code that runs it. Maybe we should put most convenient way to test this